Hello students, it's me Rizwan here. In this video, we are going to learn how to solve problems based on normal distribution using this Casio FX9860G graphic display calculator. Yeah, let's go ahead. The first problem, a random variable x is distributed normally with a mean of 20 and variance 9. So if the variance is 9, it implies that the standard deviation is 3, square root of 9, right? So find P of x less than or equal to 24.5. So we need to find the probability. Press menu and then go to stat mode, execute, and then you need to press F5, which is below distribution, and then after that you need to press F1, which is below normal. Okay, now you may see that there are three options here: NPD, NCD, and inverse normal. Now we will only be using NCD and inverse normal in uh, IBDP math SL. Okay, so let us look at this option first, NCD. Now since I need to find the probability, we need to select NCD, that is F2. Okay, now it will ask for what is the lower limit and what is the upper limit. Now since I need to find probability of x less than or equal to 24.5, the 24.5 will be the upper limit and the lower limit will always be minus 10,000. I'll always use minus 10,000 as the lower limit. Execute. Upper limit is 24.5. Now sigma is nothing but the standard deviation, which is 3, and mu is nothing but the mean, which is 20. So execute, and then you get this answer. The probability is 0.933. Okay, so that is the answer for the first question. Now the second one is, let P of x less than or equal to k be equal to 0.85. Represent this information on the following diagram. As you can see, I've already done it for you. So k will be here to the right hand side of k will be greater than 20, and this area to the left of k is 0.85. Now using this information, you need to find the value of k. Fine. In this scenario, students, the area is given, the probability is given 0.85. I need to find the value of k. So you need to use inverse normal. So exit, distribution, normal, and press F3, which is below inverse normal. And then it will ask you where is the tail? Is it on the left hand side, on the right hand side, or at the center? Now here we know this area, right? 0.85, and this is what we are going to use here. This is what I'm going to enter in the calculator. So hence this is the tail. So tail is on the left hand side. So that is fine. Area is 0.85. Execute. Sigma is 3 and mu is 20. That is fine. So press. So the value of k is nothing but 23.1. Fine. Let us look at the next problem now. A random variable x is distributed normally with mean 450 and standard deviation 20. Find P of x greater than or equal to 475. Fine. In this case, I need to find the probability that x is greater than or equal to 475. So let me use, in this case, I have to use NCD. So distribution, normal, NCD. Now here, since I need to find this x greater than or equal to 475, 475 will be the lower limit. So I'll press 475, execute. Now upper limit here, I'll keep it as 10,000, always, wherever it is applicable. Sigma is 20 and mu is 450. Execute. So you get this answer, 0.1056. So which is nothing but 0.106, correct to three significant figures. Let's look at the next subdivision. Given that P of x greater than a is 0.27, find a. Now here, so this area that you see here is 0.27. So using this information, I need to find the value of a. Now here, I need to use inverse normal because I have the probability and I need to find the value of a. In this case, since we are going to use this one, 0.27, the tail is on the right hand side, right? So exit, distribution, normal. Now this time inverse normal. tail is on the right hand side. So I'll press F2, which is below right, and area is 0.27. Execute. Sigma is same and mu is same. So execute. So you get 462.25. So 462 is the correct answer. Okay, the value of A is 462. Fine. Let us look at the third problem. A box contains a large number of biscuits. The weights of biscuits are normally distributed with mean 7 grams and standard deviation of 0.5 grams. Okay, so exit, distribution, normal, NCD. So mean is 7 and standard deviation is 0.5. Now in this case, you need to find one biscuit is chosen at random from the box. Find the probability that the biscuit weighs more than 8 grams. So that means the lower limit will be 8 and upper limit 10,000. So execute. The answer is 0.02275, that is 0.0228. Correct to 3 significant figures. Exit. The next problem is it weighs between 6 and 8 gram. So here the lower limit will be 6. Execute. Upper limit will be 8. Execute again. So you get this answer 0.954. Okay. So let us look at the last problem in this video. It is claimed that the masses of population of lions are normally distributed with a mean mass of 310 kilograms and a standard deviation of 30 kilograms. Calculate the probability that a lion selected at random will have a mass of 350 kilogram or more. So let us enter those values. Since I need the probability, again I'll press F5, F1 and then F2. Here I need to find P of X greater than or equal to 350. So lower limit is 350, upper limit is 10,000, and sigma is 30 and mu is 310. Let me check whether it is right. Yeah, 30 and 310. So execute. You get this answer, students, 0.09121. So the answer correct to three significant figures is 0.0912. Fine. Now the next subdivision. Let me cancel this. The probability that the mass of a lion lies between A and B is 0.95, where A and B are symmetric about the mean. Find the value of A and of B. Now the diagram is given here. This is not part of the question, students. This is part of the answer scheme, but I've given it here so that you can understand it better. Now A and B are symmetric about the mean. So it implies that A is equidistant from 310. A and B are equidistant from 310. So distance between 310 and A is same as the distance between 310 and B. Fine. In which case this area, you can see that this area is 0.025, this area is 0.025. Now there are one or two ways to find the values of A and B. Okay, I'll tell you all the ways. So first what I'm going to do is, now this area, the central area is 0.95. So I'm going to use that information to find the values of A and B. So exit, distribution, normal. Now this time inverse normal. Now I'm going to enter F3, that is central, right? Because the tail is at the center. Area is 0.95. Rest everything are same. Now lower limit is X, lower limit is 251.20, that is 251. So 251 is the value of A. You can see the answer 251, and 368.7, that means 369 is the value of B, right? So that is how you can find the value of A and B. Or you can also find, you can use this part. Since we know that this area is 0.025, you can go to inverse normal and you can enter the area as 0.025 and the tail is left and you'll get the value of A. Same way, if we enter the same area but the tail on the right hand side and the same sigma and mu, then you'll get the value of B. So that is another way. So I hope you found this video useful, students. Thanks for watching it.